This unit has a big mishmash of different odds and ends that we're learning about, but actually most of it is on math and doing some problem solving. So let's review scientific notation and how to switch back and forth between scientific notation and long form. You probably know that exponent tells you how many places to move the decimal, and so I'm going to move it twice to get rid of the exponent. And then because it's a positive number, I know this is a big number. So instead of backing up and making it 0.0 something, I moved to the right. This one has a negative exponent. I know it's a small number, so I'm going to move it this way. I'm going to back it up 1, 2, decimal point. I'll put a 0 in front. It's good to show a 0 in front of that dot instead of just writing dot 24. 024. Okay, on this one, I'm going to move the decimal place all the way. Kind of our standard way to show it is to put it right there with one non-zero digit in front. And again, this is a large number, so it's a positive exponent, and I moved it 4 times. We're going to look at the metric units used for measuring different things. We're going to look at what we call the base units. The base metric units are the ones that don't have the prefix. A prefix is like milli, centi, micro. It's the part that goes with those prefixes. So for example, meter is the base unit for length. We use a lowercase m. G, gram, the base unit for mass. L for liter. S for seconds. Those are what we mean by base units. The SI system of units is a certain set of these units that kind of go together. And in physics, you'll see why that it's important to stick with SI units, or it makes it easier, because they all kind of go together when you're calculating work and things with multiple units. And it's kind of what you'd think that they're kind of the most common one, but gram is not the SI unit for mass, it's kilogram. And you don't have to memorize these, I just want to make you aware about it, that sometimes it's helpful to have all of your units in a problem be SI, and then you would have to go to these. With those base units, we can use these prefixes, and you need to know these prefixes and how to use them. And the way it works is if you memorize these and you get used to writing them in order, if you have a number like this and I see the K, if I just remember what the K means, well, the K is for kilo, and that letter K really means 10 to the third. So I could just rewrite this and say 15, and then I'm going to put times 10 to the third meters. So I've converted that to meters just by plugging in what that prefix means. On this one, I have the capital M. The capital M is for mega, but capital M means 10 to the 6. So I could just say 1, and then I'm going to put 10 to the 6, but I put a times in there, grams. So I just converted that to grams. Temperature is a measure of the average kinetic energy of particles, and we'll talk a little bit more about the meaning when we get to talking about gases. But anyway, we don't usually use Fahrenheit. We will use Celsius quite a bit. You need to know that Celsius is based on water, the freezing point and boiling point of water at 1 atmosphere pressure. But anyway, it's based on water, and you don't have to memorize the equation for converting between Fahrenheit and Celsius. You do need to memorize the conversion between Celsius and Kelvin. So Kelvin is what we call an absolute temperature scale, When the coldest possible temperature is when there is no kinetic energy, the particles have stopped moving, and that is at 0 Kelvin, so absolute zero, the lowest possible temperature. Anyway, and this is the conversion for it. Also, know these relationships, that if you have a length like meters squared, that gives you an area, or a length cubed, that gives you a volume. You need to know these relationships for metric, that a liter is defined as a decimeter cubed, and that means that a milliliter is a centimeter cubed. And then this cc, you see in medicine sometimes, means cubic centimeter, so it's the same thing. And then parts per billion and parts per million, that's what these are. These can be ambiguous because sometimes they're talking about parts per million in terms of like molecules per million, water molecules or whatever, or sometimes they're talking about grams of a substance per million grams of the whole mixture. So you have to be careful about those. Let's look at a really simple calculation, density. So density is mass per volume. It's basically how much matter is crammed into a certain amount of space. And so you probably know density is mass over volume, and it can have different units depending on what you use for your mass and volume. It is macroscopic. It's something that you can see. Let's look at a simple problem for density. This one's really simple. So I'm going to calculate the density, mass over volume, and I look at my units. A lot of times if we look at our units, it'll kind of tell us what to do. Kilograms, I know that's a mass because of grams. Liters, I know that's volume. And so I'm just going to put like so. And then if I put that in my calculator, I'll get this big old long number. And it goes on from there. I know the units because I had kilograms over liters, so this will come out in kilograms over liters. And I put a question mark there because we know that we're not going to use all of those digits. It's not just that we're lazy. We don't want to write down all of those digits because some of these don't have any meaning. And we know we want to round it off. And maybe you've learned about how to know where you should round something off in the past. So if you have, can you look at that and tell me how many digits I should write down for this answer? And I should write just one unit, one digit. So the rules for knowing how to round off your answer is what we're going to talk about next.